Here we have the accumulation function, the area from 3 to x of the function 4t plus 5 dt. Here's a visual of what's going on. So we have the function 4t plus 5, and then we want the area between 3 and x. All right, so to do this, it's just like any other integration question, except when you plug in your boundaries, you plug in x. So take the antiderivative, so 4t becomes 4t squared over 2, and then plus 5 becomes 5t, and then evaluate it from 3 to x, and then plug in the x. So first of all, let's simplify this. 4 divided by 2 is 2, so 2t squared plus 5t, evaluated from 3 to x. Okay, so now plug in the x. I get 2 times x squared plus 5 times x. So I don't know what x is, so I just replace the t with an x. And then minus, all right, there's my f, that's like my f of b right here. And then the f of a part is over here. Let's just plug in the 3. So 2 times 3 squared plus 5 times 3. Okay, and then that simplifies down. Let's see, 3 squared is 9 times 2 is 18. Plus 15 is 33. So final answer is 2x squared plus 5x minus 33. So there is an algebraic expression that gives you the area of this figure. Now, by the way, without calculus, you could, notice this is a trapezoid, you come up with the function for the area of a trapezoid in terms of x, and it would actually turn out to be the same answer. But it's just easier to just use integration in most cases. That's it.